Let's look now at three of the most important electronic systems: an instrumentation system, a communications one, and a control system, to see how the building blocks discussed in the last video fit together. Instrumentation systems measure things, for example, temperature, pressure, or light levels. The measurand, that is, the thing which has been measured, affects the sensor and changes its electrical parameters. In general, this might cause the sensor to generate a voltage across itself, or another possibility is that it might generate a small current flowing through it. But the commonest effect is for the sensor to change its resistance in response to a change in the measurand. Regardless of what electrical parameter changes in the sensor in response to the measurand, this change must be changed into a voltage for further processing. Voltage is generally the easiest electrical signal to handle in a circuit. This is because, unlike a flow of current, voltage doesn't heat up the circuit or dissipate power in the resistance of the wires. We'll cover circuits for conversion into a voltage later. Next, the signal is sized correctly for the rest of the circuit by an amplifier. Usually this means making it larger. After amplification, any unwanted interference or noise in the signal is filtered out. The analog to digital converter then converts the signal into a binary form for processing by a computer. Before computers were widely available, the amplified result would be displayed on a voltmeter calibrated in the measurand units, for example in degrees centigrade in the case of a temperature measurement system. However, the widespread availability of computers has revolutionized all electronic systems. They mean that we can display the results in colorful graphical formats, store them on disks, send them via the internet, or perform mathematical processes like averages on them. Further, computers can actually be programmed to amplify, filter, or modulate signals, just like hardware circuits do, but with many advantages. These complex processing algorithms are called digital signal processing, or DSP, and their use now dominates signal processing. The computer can also be programmed to take decisions based on the information it receives, and then, using this, can affect the environment. For example, to open or close a valve or switch on a heater. This type of system, which not only monitors the environment but also affects it, is a control system. Finally, let's consider the communication system. In this example, a radio system. This starts by picking up the signal, which consists of a small voltage at the antenna. This signal can be amplified to make it larger and then filtered to remove some or all of the other stations and any interference in the signal. Next, a mixer is employed to reduce the frequency of the signal and make it easier to handle. Further amplification and filtering may then be applied to size the signal correctly and clean it up further if required. It can then be converted into a digital format for final decoding and processing. Again, in previous years, these final systems would have been done using electronics, as shown in the diagram.